Is it possible to travel to Andromeda galaxy in a year? Let's calculate that. But for that, please do like, share, subscribe, and please support this video. So today's topic is Andromeda galaxy. I hope so the spelling is correct. Okay. So I hope so that you all know that in which galaxy we are living. We are living in Milky Way galaxy, right? So what is the average distance between Milky Way galaxy and Andromeda galaxy? Well, suppose this is Milky Way galaxy and this is Andromeda galaxy. Okay, I am representing both of them using a circle, right? Okay, suppose this is Milky Way galaxy. Notice that Andromeda galaxy is slightly, means it is greater in size as compared to Milky Way galaxy. So that is why I am drawing a big circle for this. Okay, so this is Milky Way galaxy and this is suppose Andromeda galaxy. Okay, so the average distance as calculated by the physicists is 2.5 million light years. Now if you all don't know the magnitude of this thing, let me introduce you to the concept of light year. One light year is actually the distance traveled by light in a year, that is in 1 year. Okay, so how many days are there in 1 year? It is 365 times the quantity. How many hours are there in 1 day? There are 24 hours. And in 1 hour, how many minutes are there? There are 60 minutes. And in 1 minute, how many seconds are there? There are 60 seconds. And in 1 second, what is the distance traveled by light? It is 3 into 10 raised to the power 8 meter. So this is the value of 1 light year. This is 24. Okay. This is the value of 1 light year in meters. Okay. To be precise, distance traveled by light in 1 second is actually 299,792,458 meter, right? In 1 second. This is the distance traveled by light. Okay. So value of C. So C is actually 299,792,458 meter per second. Okay. So if you want to calculate this distance, this is actually 2.5 million light years is 2.5 into 1 into 10 raised to power 6, since 1 million is 10 raised to power 6 times this quantity over here. So this is the magnitude, this is the value actually, okay, of 2.5 million light years, and of course it is a very big value. So it means that if you travel at the speed of light, you will still take 2.5 million years to get to Andromeda galaxy. So how can we get there in a year? Well, I'll be using time dilation concept from a special theory of relativity. So let me introduce you all to that. So suppose this is a frame, there's an observer in this frame and he's on Earth, or let's not assume Earth because over here then we will have to take gravitation force also into account, so I don't want that. Let's assume this person is in Milky Way galaxy, Milky Way, and we are assuming that there is no force acting on this observer. Okay, okay, so suppose this is xy and this is z. Okay, so suppose there is a clock over here. Okay, so in this frame, suppose S frame. Now assume there is a particle, I mean there is another observer. This is x, y and z, and this is the observer, and there is another clock. But suppose this frame, this is S dash frame, and notice that both the frames are inertial frames, that is they both are not accelerating, right? So there's also an inertial frame of reference, and there's also inertial frame of reference. Okay, so this is traveling, suppose, with a velocity v. Okay, so suppose if this observer has to observe time elapsed for this observer, how will he calculate? Well, let's assume this person as observer 1 and this as observer 2. So I will represent as O2 and O1. Okay. So suppose time elapsed for this observer is T naught, TO1. Okay. And suppose for this observer time elapsed is TO2. Okay. So the relation which is given by Einstein is actually this. Now what does it mean? It means that with respect to this observer is moving slowly in time. That is, the clock is moving very slowly for this observer. But for this observer, the clock is moving at normal rate. That is TO1. Okay. But but for this observer, with respect to this observer, the clock is moving slowly. So that is why we have this expression. Okay, where we have gamma as 1 upon root 1 minus v square by c square. So you can also say that TO2 is TO1 divided by gamma. Okay, and gamma is always greater than 1. Okay, or it can be equal to 1 also when velocity is 0. Okay, so it means that time has dilated for this observer. That is, time, the 1 second for this observer has dilated, right? So it means that suppose 1 second has elapsed for this observer, and suppose he is moving at a speed, suppose 0.6 c. Okay, so let's calculate time which will be observed by this observer. Let's see. So TO2 will be TO1 times the quantity 1 minus 0.6 c by c whole square. So it is 0.8 second. That is, for this observer 1 second has passed, but for this observer only 0.8 second has passed, right? Okay, so that is the beauty of a special theory of relativity. That is, for this observer only 0.8 second has passed, while for this observer 1 second has passed. So it means that suppose for him, if 1 hour has passed, let's calculate how much time has passed for this observer. TO2 will be 1 hour into this term will be 0.36. 1 minus 0.36 is 0.8 when you take the square root. 0.8, so it is 4 by 5 hour. Okay, so for him 0.8 hour has passed, right? Similarly, if for this observer 1 year has passed, for him only 0.8 year would have been passed. Okay, so if for him 100 years has passed, for him only 80 years has passed, and so on and so forth. So it means that when this observer will return to this observer, he would have aged 100 years and he would have aged only 80 years. So it means he has actually moved in future, right? So that is the concept of relativity. This is a very brief idea, not very deep over here, but I hope that this much is enough to explain you. Okay, now let me erase this and explain how you can go to Andromeda galaxy in 1 year. Let's see that. Okay, so this is Milky Way and this is Andromeda. Suppose you start from here or anywhere, okay, and you start moving to Andromeda galaxy. Okay, so of course you haven't reached, so I should draw it using dotted line. Okay, so you are going in this direction, and Suppose there is an observer O1 who is at rest, and suppose you are over here or starting of the journey over here, O2. Okay, so the distance is 2.5 million light years. Okay, okay. So you have started moving, suppose at velocity v along this direction. Okay, so you are going to that galaxy and you want to travel that distance in a year. Okay, so you know the relation to TO2 is equal to TO1 root 1 minus v square by c square. Correct. So you want time elapsed for O2 as 1 year. So TO1 root 1 minus v square by c square, right? So how you will calculate it now? We have to calculate this velocity first of all, right? So T naught, because of course now I have to explain you one thing over here, will be equal to d upon v. Why? Because for this observer, this observer is moving at a constant velocity towards the Milky Way galaxy, and the distance is 2.5 million light years. Okay, so T naught is actually 2.5 million light years divided by the velocity which will be required. So 1 year is 2.5 million light years divided by velocity 1 minus v square by c square. Now you have to calculate the velocity. How you will calculate the velocity? Well, when I calculated the velocity for this thing, I got velocity around 0.99999999999. See, so this is the velocity which I had got when I calculated the velocity from this expression, right? So for this, for TO1, it was around 2.51 million years, but for observer 2 only 1 year has passed. So it means that on Earth 2.51 million years would have been passed till the time I reach to Andromeda galaxy, but for me only 1 year has passed. So for example, if my age was 25, I would have just aged 26 when I would have reached Andromeda galaxy. But probably by in next 2.5 million years, there would have been many changes on Earth, right? So probably whole Earth would have changed in this much years. But for me, only 1 year has passed, and that is how you can travel to Andromeda galaxy in a year. But the condition is that you have to move very, very, very close to the speed of light. So you can ask me that what if I assume my velocity is 0.99 c, 99% the speed of light. This is also very close to the speed of light. No. Why? Because when you calculate time for me, it will be 360,000 years over here. Of course, probably it's not possible because human average lifetime is around 70 to 80 years, or max to max 100, or 100 years, right? So of course probably till the time I reach Andromeda galaxy I would have gone. Okay, so it's not possible. So that is why we need this much velocity or greater than this to reach in a year, or less than that. So I hope you enjoyed this video. If you did, then please do like and subscribe, and please support this video. Bye bye, take care.